Du har set, jeg har svaret. Nej, det har jeg ikke. Du følger faktisk der memes. Jeg var lige for dig. Det er rigtig sjovt. Jeg havde nok faktisk nogle memes, jeg var sindssygt forvirret i kort øjeblik. Men jeg tror det ikke. Ja. Sorry for it. Ja. Okay. Just like snaps. Ja. Jeg stod og haft den der. Det er lidt vildt. Det er meget bedre belægning. Jeg har lidt en jeg tror også dårligt hvad du gør, hvis du bliver noget. Jeg havde ikke haft det, så havde jeg det. Men er det ikke lidt mere? Ja. Okay, we should start. So today, oh yes, I actually had first a preliminary note. That is, a few people reached out to me asking for projects, for instance, to think about thesis. And I tend to keep a page or a Google Sheet with project ideas that you're free to steal or to get inspired by. I might share it later. I haven't updated it yet this year, but in general, if you're interested in figuring out whether you could do a project with me, you can send me an email with either the kind of competences or the kind of topic that you would like to develop in your thesis. And then we can brainstorm something and you can figure out whether it's something that works for you. Second thing that we're going to focus on today is that you're going to be exploring outer space and learn how to survive amongst aliens. Woo! So basically what we're going to do is we're going back to the very first exercise that we did. But instead of playing the matching pennies, you will be sitting with your peers or group or mate or whatever it is. And you're going to be playing along. I'll show you the stimuli. You will be making your response. And then I will give you feedback, and then we'll do that for a while, because what we want to do then is to spend some time trying to figure out which kind of strategies in cognitive models make sense to use to conceptualize that kind of experiment. After which, depending on time, I might give you an overview on categorization models that are present in the literature, or skip straight away to how to implement a very specific model, the generalized context model, and give you the overview next time. because I want to empower you, no matter whether you have an idea that you buy into to do cognitive modeling of these tasks or not, to be able to start the last assignment tomorrow. So you can either work on your idea or have an example of a model that you can adjust to the task. Questions? And just as a reminder, assignment 3 is formally due next Friday, I think it was, something like that, Thursday or Friday. It's not a hard boundary in order to get feedback. And tomorrow we start assignment 4, which is the last assignment. Next week, we will also have to do the final evaluation. No, because then I have to summarize it and potentially discuss it on the last lecture, because according to the rota, this is my year to actually submit the full evaluation. Good. Before we start, are there questions, doubts, things that you want to bring up? Good. So the alien game is, let me actually just run it. And then it would take a second to start, but it is actually a real experimental setup that has been used in at least one paper, actually 2 papers that are out to study how categorization changes in dyadic contexts. So when you go from being one cognitive system that solves a problem to being a dyadic cognitive system where 2 people are solving a problem together. We are now deploying it in the States and in Israel to investigate categorization processes in autism. In the States, it's about how adolescents with autism are able to make joint decisions and categorization with their caregivers. And one of your Tugsai fellows from last year wrote her her master thesis on how different models for these kind of setups, which actually landed her in a PhD in Tilburg because they liked it very much. Good. So let me just put some random. And we're going to do 30 trials. I'm going to make it easy for you. Okay. All right. So the idea is that you are a pilot in outer space. You're a crew of pilots in outer space. And you're exploring and meeting a bunch of wild creatures, aliens like this. And these wild creatures might be dangerous or not. Might be exploitable or not. Right. So, of course, as any explorer in outer space from a Western country, you're trying to colonize and exploit before aliens. And so the idea is to figure out whether you can extract from them a certain valuable jelly that you can use to make money or enslave other alien races, right? And so you don't know in advance which are dangerous or not, which are valuable or not. Right? But as you see these aliens, you need to make a decision. Will you shoot the alien because it's dangerous and then tap their valuable jelly? Or will you just shoot the alien and leave them lying on their planet or floating in space because they're dangerous and not valuable? Or will you just tap the valuable jelly from the alien? Or will you just ignore the alien because it's not valuable and not dangerous? Right. Are the 4 categories clear? Good. After each encounter, right? You will get feedback, right? If you didn't shoot the alien and the alien attacked you, you know whether it's dangerous or not. If you tap the alien and nothing was inside, you will know that it wasn't valuable. You can discuss with your group as much as you want to figure out what you should do. Yes.
So there's one category that's dangerous but not valuable.
Yes.
Okay.
So dangerous, not valuable, dangerous, valuable, valuable, harmless, not valuable, harmless. You're free to talk in however way you want. The goal is, of course, to gain as many points as possible. Every time you guess, you get some points. Every time you're wrong, you lose points. By the way, my daughter is really pissed I didn't bring her with me to work today because she really enjoyed doing it last year as being the guinea pig where everybody could see how she would pick it up. And she had trained and learned all the aliens by heart. Okay. So basically, the heart is not dangerous nor valuable. You're just petting it. The science thingy is just valuable and harmless. The skull is you're just killing it, shooting it. And the skull and then the science thingy is you're first killing it and then exploiting its body. Corpse. And actually, we had to change the framing to get it through the IRB for the autistic adolescents in the States. They had no sense of irony. Okay. So you're only going to see the aliens for a short time. And then the alien will disappear and you can figure out what to choose. But you can start speaking as soon as the alien appears. Okay. Yes.
Do we know how many points we get for the different correct or not correct?
So it's actually only the exact button will give you points. Everything else. So if it's dangerous and harmless and you shoot it correct in a sense and then tap it, you still lose points. Ready? Can you all see the screen? Good. So for the people of the Zoom, try to do it at home. You're seeing this.
Because what you just said is that if it's dangerous and invaluable and you tap it,
Yes.
then you lose points.
Yes.
Yeah.
Even if you shoot it
Yeah.
and tap, you lose points.
Yeah.
You have to be absolutely right. Good. So if you are successful, so if you get the right button, it's 100 points. If you fail, you lose 100 points. We'll start. Maybe. Okay, so discuss it, and then I'll pick a group.
No, why not? If I'm wrong, that's okay. I'm thinking that the first choice is I have no learning about without asking. But you have to be better at saying these points. But if you don't have any so you got to exit stage where you don't the point. Yes, yeah.
Have you all reached a decision?
Can you get minus points?
Yeah.
Yeah, okay.
Well, we'll start here. What's your choice?
Can I tap?
Wrong. You should have ignored this friendly alien. Next alien. Please note if you got it wrong or right, just for the fun of it. Okay. We'll get this group decision. What's the decision?
We will only test.
Only tap it. Great. Wrong. You should have killed this dangerous alien. Okay, so this group. Yay. So Ingrid? What, sorry? You killed. Wrong. You should have tapped this nutritious alien.
So it was dangerous.
That's the feedback you got. You didn't get any feedback from that.
Yeah.
This one.
I guess
This one.
So your group?
Whoa.
Okay.
Okay, let's say.
You should have both killed and tapped. Killing is hard. So the choice is ignore or Your choice.
But it has, it's nothing.
What do you say?
It's not, doesn't have a gel.
So what are we doing? Are we ignoring?
Hit it and nothing else.
Hit it.
You should have tapped this nutritious aid. Your choice? Kill. You should have ignored and patted this friendly alien. What's your choice? Good. Ingve? You should have tapped only this nutritious alien. Your choice? No, behind. Tap. Good. You have a 2 out of 2 correct ones.
Okay. Men vi bliver tappet, når der er normale omstændigheder. Nej, lad os sige. Så vi vil ikke have den ikke brugt så.
Nej, jeg tror ikke.
Your choice? What, sorry? Good. No, you should have ignored this friendly alien.
That's dangerous.
I think that she played it 4 or 5 times before really getting the rule, and then a few more times to get it perfect.
You said the rule as a singular.
Well, so the system that you use to generate the correct decision. Yes. Kill? You should have ignored. The experiment is now done. Thank you very much for your participation. Okay. So, right. So now what I want you to do is to take actually more than a moment, to take like 5 to 10 minutes to sort of identify either the strategy that you use to solve this task or tackle this task, or like kind of models that would make sense to use to understand what participants are doing, especially based on what you know on the cognitive.
Yeah. Okay, then.
Also, remember that there is a twist. So in the original paper, what we had was individuals and pairs, right? Here we have groups, right? So what you define as the cognitive system will impact the kind of models that you can conceptualize, right? If the cognitive system is the individual, that will sort of tell you something about how to model this task. If your definition of the cognitive system is two cognitive systems connected, then that will shape things differently. If it's a global brain, right, that will also have an impact on how you conceptualize. Good. So let's say we take 10 minutes and then ideally write down your ideas in the anonymous Google Docs with the questions, because that allows me to sort of have all of those ideas in one place so that I will also be able to comment on all of them beyond this discussion, but in the rest of the lecture.
Hvor mange features er der?
Og så har hun bliver endnu mere brændt til at gå i den retning, fordi det svært at gå i at den her ord, den samme skæld, så den havde været stærkt om at det er rigtig værdigt. Det kan jeg nok ikke sige, det er så det er sådan nogle dyr i, at vi har nogle steder på hånden, ja, det er ikke så meget. Ja, det er ikke så
Det er mange, ja. Det er nok kun dygtigt. Ja. Jeg føler også noget. Nej, ikke selv, så ikke også det fokus, eller hvis man har en vægt, så er det rigtig meget godt. Jeg skulle sige, der er en tidspunkt, hver gang der er vedkommende selv, så gør vedkommende mærke til. Ja, så må det være færdigt, fordi man har en højt vægt for den farve.
Men det er så meget naturligt. Nu er fritaget her. Måske gør man altså lidt for sådan.
Ellers skal man.
Jeg ved ikke, om det var...
Det er jo mange features, der er fordi der er farven, der pletter på farven.
Og vi nåede til at regler, der er mange bagskaber.
Ja, tykker på det.
Måske har det været en til at sige, eller ikke øje, det skal ligge bare lidt. Og der er vi nok ikke, der ender. Ja, det er måske faktisk, der er nogle fejl, som nogle vigtige. Ja, det er faktisk en translate, den sammen. Men det er faktisk også på ulige på bedst, tænker jeg. Men når du tænker på det ene, hvor vi så den kan vi godt sige, at det er næsten hvad vi vil.
very meaningful.
Ja, og det må jo så være yellow eyes. Men probably så hvilket aliens den gang får. Ja, det er der vil. Også fordi feedback vægter man. Men det er det, jeg synes, at det er interessant, hvilken stil der har gjort det.
Men det var også
Skal man have
Hvad er det, vi ikke evaluerer på?
kan man have flere vektorer, og så man har ligesom, hvis man overhovedet ikke tænker, at farver har nogen betydning for læsbegreb, eller whatever man siger, så vil den bare være 0, og så implicit er det correct. Altså, konsekvenseret ved, at vi alle sammen er i det. Altså, at det diskussion mere til at de kan sige, at ligger lidt assumption. Hvad hvis man bare overhovedet ikke vægter den? Så er det bare, du kan ikke med af det. Eller skal det? Så er det bare en way, som du ikke bare... ikke vægter. Du ikke nødvendigvis hvis der er noget vægt, så kun vægter og øjne, som de eneste ting, der påvirker valg af de to, så man siger, at de eneste indflydelse, der vægter, der har en værdi. Ja, men så skal det summere til en. Hvad hvis jeg ikke? Hvis man ikke altid at jeg hvis jeg ikke vægter jeg ved bare der må være et det også være sådan der skal være en eller menneske vejer har alle 6 det føler jeg ikke. Jeg kan ikke okay, hvis man løser det her så skal man tage højde for
vi har en regel,
i relationen det kan være at det skal være 3 teachers der er så iterativt så ja assign
så på en eller anden måde skal vi jo her runde
der er også nogle grupper til ja det er det vil være næste lag tænker jeg det er faktisk ikke bare individuelt har den når man version er meget bias jeg vil ikke meget det betyder at jeg kigger tilbage jeg synes det er repræsenteret i meget jeg er bare sådan man tror for hvornår man i forhold til
jeg tænker, det var ikke kun den her regel.
Er det mere sådan
Jeg tror, vi forsøgte måske at gemme ud af den, men sådan at der kunne være en reaktion. Det blev lidt, der ville måske være lige
vi tror, der er en og så
Så kan man
den begynder man at vide, hvad det er for det der strategi. Okay. Men okay, men det vi snakker nu, at det er selv eller hvordan
Men så lige og så bliver det på en eller anden måde skal være
vi skal også føre til højde. Skal man have uniform? Er der nogen?
Begrænset af
Jeg tæller, at der er nogen, som jeg ser det generelt, som er nødt til at være stærkere.
Der er ikke attention. Ja, det vil man ikke.
Okay, ja,
Det er selvfølgelig for at starte med at farve.
ja. Og at eksempelvis den, der står armene, det virker også. Ja, og der fortæller, at der er mere.
Ja. Jeg får lokale informationer til
So start jotting down your ideas because we'll soon start discussing together.
Jo, Blackson, jeg har ikke sagt. Blackson ligger inde, så hedder det underkøbsformat. Men måske man skal sjov med
That's me initial theory about. Make that more smart than about B.
So what's wrong?
Yeah, that's, yeah. That's,
Ja, der er lige, der har lavet det, men det er faktisk, det var virkelig til dig, så ja, men jeg havde lige en dag, jeg siger, jeg faktisk lavede nogle ting, du ikke kan komme tilbage.
Okay, so does somebody want to start by explaining which kind of strategy or model you would like to, well, you've thought of and discussed? Yes.
I feel like our strategy started being more simple and then it sort of developed. So in the beginning, it was sort of looking like at a single feature, for example, the color.
Yes.
But then we figured out at some point that that was not enough.
Mm-hmm.
Then we sort of needed to add interactions between.
Okay, yeah, so.
Between different. But that didn't work either. So.
Yeah.
Yeah.
Which kind, can you give me an example of interaction?
It could be like if it's blue and it has its arms up.
Mm-hmm.
Then
So it's an and.
yes, yeah.
Okay.
For example.
Yes. Yeah.
You see, the overall thought process, we're trying to track which appearance dimensions are the important ones.
Mm-hmm.
We also discussed that there might be something like color might be more salient to people. So we
Mhm.
might start with some features or like value some features more than others in general.
Yeah, and
So
then,
I'm gonna say not natural, but initial saliency.
and the fact that there was a limit to how much we could remember, and sometimes we forgot what it looked like, so we need to add some sort of constraint on either the attention, memory. So.
Yeah. Limited. Yes. Okay, so a couple of comments. The first one is that you are of course assuming that there is a given feature space. A pre-given feature space that you're sort of exploring and trying to figure out in which region of the feature space the different categories lie. Right. And of course, there's something that we haven't discussed, but will probably come up in different groups, that we don't know the features in advance. Right? We see the features, but we don't know what is a feature and what is not in advance. So for instance, I remember many were talking about teeth at the start, but teeth are basically invariant. But that's part of the intriguing part of these things. The second one is that it seems that what you're dealing with is what in the field is called a rule-based categorization, which is trying to find these more logical associations. Often the rule-based models of categorization are called the verbalizable models where it's easy to express them satisfactorily in words. And then you're saying that the feature space is not neutral to start with, it's not homogeneous, but there are certain things that there is a landscape of saliency to start with. Yes, Svante?
We discussed that exactly a rule-based model was probably even more likely to happen here in a combined context, because exactly it's easier to communicate. So we might have some vague intuitions in the first couple of rounds, but the only one I was able to communicate was, oh, this one was green. And
Yes.
there was a similar kind of thing that we did that was also easy to communicate, that didn't we didn't use a lot, but a couple times where we didn't know the features yet. So instead we just refer to, oh, do you remember those first two trials? This one was that and that one was that. So more of a kind of exemplar
Yes.
based representation where
Right.
we were trying to remember back at that to learn from that again.
So that was Alien Joe and that was Alien Jill, right? Yes.
And oh, this one is more similar to the first one, so let's guess that.
Right. Good. So this is another kind of model which is called exemplar-based categorization, right? Which basically, oh no, I forget the name. I should know. Is that the K-means or SVMs or a lot of these models try to build boundaries between categories by looking at distance from the known exemplar. We'll get into the really messy thicket of the theory. Now we just want to go through that. These about language and social interaction is actually quite crucial, and it's because a lot of the models that we've seen before, let's say reinforcement learning, are not rule-based, like they're probabilistic. And there is a big debate as to when do we use these more implicit models, when do we use these more explicit models, how do beliefs emerge? And there are a couple of experiments using a similar paradigm to this, where somebody is piloting a spaceship and shooting aliens, and somebody else is sort of looking outside at the aliens and giving instruction to try to disentangle whether it's just an effect of using language, so verbalizing your experience, or the actual effect of talking to each other. And the jury is still out. We don't know. Though the effect is bigger with the social interaction. Were there other points from your models here?
Yes, we tried a different approach, which is say what would an optimal kind of model look like?
Yeah.
And based on that, and then so one that would be optimal if there's no memory pressure, no attention pressure, or anything like that, would be just remember everything.
Yeah.
And do naive Bayes or something. Just count up the combinations of features, and over time you'll learn them.
Okay. And that, of course, would, okay, two aspects. If you adopt an naive-Bayes option, of course, you assume that you know all the features that are there in advance, which is not a pre-given in your experience, right? You were looking at teeth. Teeth were not varied, right? People might not have immediately noticed that spots were a feature, because I can remember, let's say that the first alien didn't have spots, right? So it's hard to know that that's a feature. The second one is, how does naive Bayes deal with interactions?
Yeah, you would have to have the space for that already.
In terms of interactions, right? Meaning, these kind of, a lot of these classifier models work on a feature by feature base. So that means if the feature independently contribute to the outcome, they're optimal models. If it's a combination of features that where the value of one feature in terms of predicting the outcome depends on the actual feature represented in the other feature, well, in that case, you need to explicitly pre-code that. And the space of combination, even with these limited amount of features, let alone in a realistic world, is pretty tough, right? So it would at least seem to require some sort of online generation of possible combinations so that you don't have these very unrealistic early space, right? Which, you know, it might happen through the experiment, or you might say, oh, but our deep neural network has already learned the important combination of features by pre-training on a different corpus, right? This is going to be another theme when we discuss theories of categorization. How do these theories of categorization relate to the practice of classification in machine learning? Right? Because there is a lot there in common. Yes?
So anyway, this then leads to the next discussion, which is how would an optimal model or machine look like, even given memory constraints and given attention constraints?
Yeah.
And given that we don't know the features beforehand. And so there should be some kind of trade-off between like exploring the feature space and like for some of the we didn't even notice that they could have yellow eyes until like the third last trial or something like. We should have noticed that before by devoting more resources to that rather than trying to make up rules. So some kind of trade-off between, I mean, you could call it exploration exploitation, but
Yeah, yeah, there you go. So in the sense of, are we evaluating the features that we already know?
yes.
Or are we devoting resources to figure out whether there are other features? Value.
And for example, we experienced that once we had learned, we thought we had learned one rule, we were able to pay less attention to that and compress that rule.
Yeah.
And okay, the spots are dangerous. Now we can pay attention to something else.
Yes.
And slowly,
Which of course also assumes that interactions are limited.
yes.
Yes.
Yeah.
Anybody else wants to bring up other issues? You had very good points about communication and
Yeah, so I think we talked about like how to model that we have like several levels of choice to make, I guess. So you can make a choice yourself based on what you think, but then once you have to discuss it, there's like a shared choice that has to be made that has to include to at least to pick some choice, you have to include some level of uncertainty or certainty from each person and how to do that. So yeah, I think it depends on whether you want to model it as like, then it becomes kind of not hierarchical, but there's still like these levels of decisions that you have to make. So you can't just do it all at once. You have to kind of revise based on the person's choice.
yeah. Good. So this is a common problem when we look at decision making in any outside of the psychophysical lab context, that suddenly there's lots of things potentially coming in the decision making system, and defining the boundaries of the decision making system is non-trivial. In this specific case, the decision making system could be set, to simplify to be the group. We don't care about what happens between individuals. We just abstract away and say there is an information processing system, which is analogous to what an individual would do, right? And we just model the input, whatever internal process we assume, and the output of these. Another would be to say, no, actually, it's individuals making choices. So for instance, we can take one person as model it as whatever our decision-making system is, the second person doing the same, the third person doing the same, and then modeling the joint output that comes out simply as a combination of these decisions. So imagine in machine learning, right, random forests, all sort of ensemble learning models are working that way. You take a bunch of simpler algorithms, each of them does its own thing independently from each other, and then they combine their expected choice using some sort of rule, right? It could be a majority rule, it could be an average that takes into account the confidence, blah, 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 right? A third way of modeling these sort of things is actually to include in the model some sort of communication system, right? Where individuals are not just making their individual decision and that sort of gets averaged or squeezed into a joint decision, but there is a communication process that's dependent on what the individuals are recognizing, terrible word, but what people are saying and the way they're saying it feedbacks into their own and the others' internal processes, right? Which is the mess, but it is very interesting. And these all ran is just to say, right, in these kind of settings, it becomes even more clear that all models are wrong. Right? Depending on what you think is important to investigate, you'll have to make choices because you cannot model everything. And by making choices, you cut away important parts of reality. And that's the torture and the fun of making models. And with that, I think we should take our break and then we'll resume the discussion after that. Let's take 10 minutes. Okay, we should start again. So, yes, we might give it a minute more because not everybody's back. But, is there in the meantime additional points that, so for instance, your group, what was the strategy that was coming out of that? Yeah, really much. Yes, I'll have this.
We also discussed race. Individuals. Those and voices. According to both how often can they be correct and how soon do they sound.
Weights by individual. So in principle, right, however you do the single choice, you could say, well, then we get feedback. And if that participant has gotten it right, we might have some rule, reinforcement learning rule, a deterministic rule, whatever that says the value of that person vote gets up and the value of those who pointed to a wrong choice, they go down. Good. Probably in implementing a model, you would start by saying that weights are pretty even. Some people have a higher weight, some people have a lower weight. And you want to estimate that. And then if that works, you can implement the online update of the weights, just in terms of modeling strategy. Good. Which kind of rule were you using to make the individual or imagining that individuals would have?
Well, sorry,
Which kind of mechanisms would individuals use to reach their own choice?
Oh, I think, well, language, with language, but I think we also talked about like there could be other features that led into others' perception of your confidence or whether or not what this person thought was right, the correct answer.
Yeah.
So maybe stuff like that, how persistent you are, maybe how like the volume of your voice perhaps.
Okay, so you it could also, yeah. So it could be some sort of well, confidence, however it's expressed, right?
Yes.
Yeah.
Yeah, it could also just be like questioning like extroversion. Or
Yeah.
something like that. But we talked about a lot of different parameters about that.
And what about how, so before you had a choice in the confidence, how would you reach that choice before communication?
Yeah, I think that was like the other group said, we were trying to look at individual features first, and then I also think it got more complex for us that then we try, okay, then there's probably some interaction between these features. Yeah, I think, and then, and we also, I think we also talked about like the whole, like for this to even be, I think you somehow have to be able to put into words what your own process is, and that can actually be quite hard.
Yes, and that will probably filter the information somewhere.
Yeah.
Which could be good or could be get bad.
Yes.
So for instance, as Malte was saying, right, getting at these potential rules is probably something that's facilitated by language.
Yeah.
That group?
I don't think much to add, but we also use the feature kind of feature space.
Yeah.
Gradually, and we were quite successful initially. But then there was a breakdown. Like our rules sort of didn't apply, and it had to be heuristic more than that, and we sort of realized that there was more complex. Interaction with mentioned.
So, what do you think was the tapping, so valuable, nutritious trait? What was it associated with?
I mean, for the longest time, we thought it was the strong. Oh, the alpha. Yeah, the alpha.
Yes,
Alpha.
that was it.
That was it.
That was it for the nutritious axis. What about the dangers?
The spots and something else that we didn't figure out about.
Yes, I can't remember the exact rule, but it was at least 2 out of 3. And these is what baffles both humans, but even more models, because it brings the interaction space. So if you add an or, it brings the interaction space, so the space of possible interaction to a very broad range. But actually, over the course of, well, at this level of complexity, they're easy. Over the course of, I think the original run was 96. 3 times 32 aliens. Actually, most of the pairs would figure it out. When it gets more complex, then it's a different issue. What about these Ingwe and the group there? Oh, it was, so now we covered your models and different components. If there was something to add from what you had.
I think so what I thought of this, I'm also thinking like the whole the communication part is going to be very difficult to put in a model.
Yes.
Because I think it's very like extremely. I mean, it's obviously what's going on, right?
One thing.
We had one other kind of template or beginning of a thought for a model, like how would we actually program an algorithm or a generative process to do this, which was attempt somehow have a procedure that's like add or modify a rule. Start from nothing at all, and we tried this simple rule with one feature, and I think in this framework, it could even just be a growing feature vector, where you have all the data that you know about, but if you learn about a new feature, you just add one more to the feature vector. And in this framework, you could even have multiple features have importance. I can at least see how you could try to. And then, for example, when do you update them? And there's some balance of how many new rules can you propose every round. You could have something related to memory with that, and some balancing of like what happens when you disproved a rule, when then you can try to amend it, either shut it down or try to add something else to say it was a spots and something else. But anyway, having that as a base, kind of having a list of rules that you build up and break down and change.
Yes. So this is, I think this brings up 2 very important points. One is if you think about the individual versus dyad contrast, it gives a very obvious mechanisms where dyads could be better than individuals. It's because you can test hypotheses and keep them in mind in a more distributed fashion, right? You can test twice the amount of hypotheses and keep in mind 1.3 times or something like that. The second is that this is something that, like a list of rules that grows over time, that goes a bit against the kind of very statistical models that we've seen so far, right? That are updating values. But it's something that will become very natural in other frameworks like ECTAR. So I was discussing how to model these experiment at a workshop in Leiden in January. And people from the ACTAR world were actually just, so you know all what ACTAR is? So the guy who wrote your Intro to Cognitive Science handbook, Anderson, made his career by saying we should stop doing this piecemeal modeling of cognitive processes. There's a model for memory, there's a model for attention, there's a model for these and a model for that. We should actually build a consistent architecture where all these different processes could be implemented in a way that, in a sense, we have a synthetic participant to experiments that would have everything from the perception to the button press kind of things, where we can actually, in a much better way, sort of see which different components can be fit and blah, and blah, and blah. And he did that in a way that is very, very friendly for symbolic cognition. So for figuring out rules and updating them on a trial by trial base, which one, keeps being reinforced in memory and which one sort of fade away. That's something that's harder to do with other frameworks. I think I had a brainstorming about this with Peter and a few others, and this is what we came up with. Something like set. So the real space was 6 features. But people might come up with different features, for instance, teeth, right? So there is a set of 6 plus 0 to n features where n is to be estimated, each with an equal weight, summing to 1 to start with. You randomly sample 1 to m features that you can pay attention to in a given trial, where m is to be estimated. We make a decision, of course, the first is at random, from those features only. Feedback allows us to update weights of the features observed independently from each other, and then they're renormalized. Why independently from each other? Because we thought that it was already getting too complex. Then the next sampling of 1 to m feature is according to the weights. So weights that have become higher will tend to sort of be indicating features that we will pay attention to again. And according to this feature and their weights, we can check the decision, get feedback, and repeat. And when we have groups, right, we could model one, do these just to describe the behavior of the group, or we could have one model per person and then aggregation of the decision rule, or we could have one model per person, including a mechanism for dialogue, which would, and then aggregate the decision rule, and the mechanism for dialogue could be that I do the random sampling of the 1 to n feature, right? And then I express one of them, right? I say arms, and that updates the weight of everybody for arms, et cetera, et cetera. Or we could have that features can be named based on weight and used to form logical rules. And then a meta decision mechanism will then attribute weights to rules versus statistical learning update, right? So we would have the rules, arms are what matters, or are either arms or eyes on stalk is what matters, versus should we just keep on updating all the features? They could actually be weighted one against the other as mechanisms. That would never fit, but we thought it would be fun to try. Good. This is my note to me saying skip straight to the GCM. So what I'm going to do now is I'm going to introduce a specific model that can be used to model these tasks, which makes very strong simplifications, but it's one of the dominant models in the field. And then next week, we're going to zoom out and say, what are the alternative models and how do they relate to classification and etc. Good. And then I need to figure out where it is. Here. Okay. So we have the generalized context model was introduced and successively championed by Nosovsky, and it's one of the most influential models of categorization processing. If you look at any paper or any book on computational models of categorization, the generalized context model is one of those that are always mentioned. There is a paper from 2011 where there is some sort of overview of the model at that stage. The idea of that model is that the features are pre-given and pre-known. We know that there are 6 features, and these are the features. Arms, legs, eyes, spots. Color. Yes, color. And maybe it's only 5. I think it's only 5, sorry, 5 features. As you experience exemplar, we should make a dance. As you experience these exemplar, and you get told, let's say, by your parents, whether it's dangerous or not, you store the exemplar as a vector of values in these 5 dimensions in your memory. Then you sort of sort, so and not just anywhere in the memory, but in the pile of the dangerous exemplars, or on the pile of the nutritious exemplars, or blah. Then, in the simplified case, it's only dangerous, non-dangerous. The GCM builds 2 sets of exemplars, 1 per category, and now the training phase is over. It has seen all the exemplars, and now it uses these 2 piles to categorize or classify the new stimuli or new instances of the same exemplars that the subject will encounter in the world. And the test phase usually is defined as there are some new stimulus. Let's start with 1. This stimulus is put in the feature space, and then we calculate its Euclidean distance between the vector in 5 dimensions and all the exemplars in the dangerous set. In the simple case, we just apply the Euclidean distance, absolute Euclidean distance. If we assume that some features are more important than others, then we can do a weighted Euclidean distance where the certain features will matter more. Right? These weights are pre-given. Then we calculate the similarity between stimuli using an exponential decay function on the distance, meaning that the similarity does not have a linear relationship with distance, because there could be a trade-off. Like if you're very close, if these exemplar is very similar to exemplars you've seen who are dangerous, it will be categorized as very strongly similar. But if it's a bit further away, it will be much less similar, right? You have this decay. And we can estimate how fast it decays, right? Now, that means that we have an average similarity from dangerous and an average similarity from harmless, right? And we can use these 2 values basically in a softmax function to identify the propensity to pick dangerous or not, right? If you have 2 orthogonal categories, you just do it across the two categories, right? Or make 4 piles. It's equally fine. And in particular, the original GCM tends to use the, I don't know how to pronounce that, Luce, whatever rule that Josh always rants about, which says that if we want to look at the propensity to pick danger, we take the similarity to the dangerous exemplars divided the similarity to the dangerous exemplars plus the similarity to the non-dangerous exemplars. Does that make sense? Does it seem like a good model? Yes.
Bring the last part again.
The last.
Similarity.
Oh, so basically the idea is that you have 2 values of similarity, and these values of similarity on each on their own, so how similar it is to danger, is not going to determine on its own how likely you are to pick danger, because it has to be weighted by the relative distance between the 2 piles. And the formula to sort of normalize that to 1 is to say, well, let's take similarity to the first pile, similarity to the second pile. That's the total similarity that we use to normalize. Then we divide similarity to the first pile by that, meaning how much of this total distance, or sorry, similarity, is actually determined by similarity to the first one. Yes.
What then do you do when you have 4 files? You calculate the distance between all combinations.
Yes, so you use so you have distance from all 4 if you're using 4 piles, and then you have that the probability of going to the first pile is similarity 1 divided this total. The probability of going to the second is blah blah blah, right? Then basically you have a list of probabilities that sum up to 1 that can be used in a categorical function to produce one choice. Yes.
Is there a reason why these weights are pre-given? I'm just thinking that it might, like if you have only one feature that's important, and then you have 4 other features that are sort of, if they don't really matter, yeah.
This is a very good observation. So the model is very clever.
Yeah.
It has lots of weird things. For instance, we would imagine that as participants are going through our experiments, they're actually learning which features are relevant, which means that the weights would have to change over time. If we don't change that over time, we are making a simplification that we should be very aware of. Okay. The reason for that is to make the model fit. So that there is an extension of the model called the alcove model, which is using neural networks. I haven't really studied the alcove model, so this is my understanding of the alcove model, that it uses neural network and back propagation to sort of be able to approximate how weights change. And Josh tells me that he had cog-sci students writing, I think it was a master's thesis on that, and they just couldn't get parameter recovery to work. But it is a big problem in the field. Something that Sarah Ostergaard, who wrote her master's thesis on this task, on modeling this task last year, did is simply say, well, actually, if I'm interested in this learning over time, what if instead I take the 5 features and run 5 parallel reinforcement learning models just on that? And then the plan was to actually constrain the value so that it would sort of be dependent on each other, but it was one master thesis with one person. The sensors thought already it was a lot. Because there was a lot of stuff, not because it was really good. Good. Another crappy thing about the model? Yes.
So naturalistic that it's split up in a training base and test base.
Yes, exactly. When you started this paradigm, you hadn't seen any of these aliens. Of course, we could make a very strong assumption that your experience with beings in the words and aliens on TV gave you some sort of priors, but that's kind of a crappy assumption, right? Well, it might be there, but you're still changing them over time because raised arm would be more natural to associate to danger. I heard several groups who were doing that, right? Yes.
It's just another thought. So I think the splitting it up into 4 piles
Yes.
is maybe, wouldn't it make sense to kind of do this twice? So do it to figure out whether it's dangerous, and then to do it to figure out whether it has gelling.
Yes.
Or, yeah.
So in the model that we implemented in the paper, the social route to abstraction, that's what we did. We said it's two orthogonal binomial or Bernoulli choices. Yes, perfect. The specific ways of implementing, right, it depends on how we conceptualize the task. But you're right, I find your way more intuitive. It, of course, opens the question of, should we sort of reciprocally constrain the way that value is attributed, the weights of different features from one task to the other? Because we could imagine that in the human cognitive system, there's going to be some leakage, right? Meaning that if you know that arms are very important for nutritiousness, that might sort of leak into also your decision for danger, or vice versa, right? You might say, no, that one was for nutritiousness, it cannot be for danger, right? Good. Yeah.
We haven't discussed memory or attentional constraints much for this model, and I don't see how it would generalize to something. If you had an experimental setup where you had more than 6 features, like how would the model, it would just assume that, oh, you remember all 12 features from the start?
Yes, so this model assumes that you know and keep in mind all of the features.
Every time, yeah.
Exactly. The attention, though, is given by the weight.
Yes.
So if you have a weight of 0, you're not paying attention to that feature.
But like it was mentioned, that's not updated over time.
No, exactly. That's a big assumption of the model. I think that there is a cool thing that I just want to bring up is that, oh yes, Andreas? Yes.
So we just say that the first trial is random, and then from that on, each new trial would be a test.
Yep.
And then afterwards it will be put in training piles.
Yes, hold that thought because I'm getting there in the next slide. Right. So since I haven't studied cognitive modeling in any course, when I arrived to this model, I was very puzzled by these training versus testing assumption, right? It sort of makes sense to a lot of people in machine learning because that's how you do it. It made sense at that point in the book, in the history, but I went and dug into what happened, right? So the idea is that in the very early paper in which the generalized context model is discussed, it is discussed as a model of category learning, right? Therefore, it's sort of dividing the training and the testing phase is kind of weird, right? Because we want to process how the categories are learned. Yet all the implementations are split into a training and test phase, right? There is a learning phase, but it's sort of behind the scene. We assume it has already happened. We have put already all of these exemplars into 2 piles, right? And what happens is that experiments start following the form of the model, which from a science and technology studies, from a philosophy of cognitive science is kind of neat, right? What happens is that in order to be able to apply these model, the mathematical psychologists, they take their participants, expose them to lengthy training phase, sometimes even hours, of looking at these exemplars, being told repeatedly where they are, being exposed to these exemplars again, so that the experimenter could be sure they had somewhat stored these two piles of stimuli. And then a test phase, and the model is only fit to the test phase, right? So even the experiments that don't do this, that don't have people going through an extensive training phase, they still assume that the model has already seen all the stimuli. They fit the same model that is supposed to be already trained, so they put a memory of all the existing exemplars in the model before they fit it to the experimental participants' data to estimate the weights and the temperature in the decision. Right? Which is kind of intriguing. And everywhere I tried to dig into why this was the case, though I had my suspicion, was that this was due to mathematical elegance and or computational constraints. And I think that really it's due to people fitting these models in a time where, of course, computers weren't as easy to run and where maximum likelihood estimation was the standard. Because Sarah and me, with a lot of swearing, which in the hindsight, yielded a very intuitive solution that, of course, we should have thought it very easily of, but we can actually get the model to work instead, not assuming a training phase, right? As Andreas was saying, we can assume that the first exemplar gets just chosen at random where to put it in the pile, but we get feedback, then we put it in the right pile, right? We keep picking at random until we have at least one exemplar in each of the piles, and then we start applying the rule. And we can still estimate the weights, assuming that the weights don't change over time. Good. So what is the mathematical formulation of these model? We have a distance, right, which is the distance of your stimulus from each of the exemplars, squared, because we don't care about which side, which direction it is, it's just the absolute distance. We calculate that for each of the dimensions, the features, and weight them. Then we do the square root, right? Basically, it's Euclidean distance. It's the absolute, the square, the power of 2 of each of the distances summed up over a square root. We have that the similarity is the exponential decay, right? It's an exponential of the distance with an exponent c, a scaling factor. What is the scaling? Well, if we have a low scaling of 0.1, this is how similarity decays with distance. In the red for the people of the Zoom, as we increase c, we can see that the drop is steeper. And then we have here that the probability of picking a category is the Luce or Luce or Luth or however you pronounce that axiom, right? Does that make sense? So basically we have two parameters. We have the weights, right? The vector of weights that sum up to 1, which we need to estimate. And I made a mistake before. I said the temperature, it's not the temperature, and we have the scaling parameter for the similarity function. Those are the parameters that we need to estimate. The temperature is not here, right? It's just taking the row Luce, I'm going to pronounce it, axiom. Yes, exactly. This is what we were mentioning as an exemplar-based model of categorization with fixed attentional weights summing to 1, which are not at all trivial to transform into learning weights with a training and a test phase, but we're going to escape it. And with a similarity to exemplar rule, which is an exponential decay. It's very elegant, right? It's very limited, but it's very elegant. Does the model make sense to you now? The basic intuition, right? So we can do it as a DAG, right? We have the choice that is absurd. We have which category the choice, the exemplar belongs to, right? Basically the feedback that you get, which is absurd. And we have the features, which are absurd. Then even, why did I put a bias? We could also put a bias, but we don't need it. Maybe I just got excited about previous models with biases. We could put a bias, but there is a rate of choosing the category, which is determined by the similarity, which is determined by the distance and the scaling. And the distance is a function of the features and the weights. Right. And then there's the what it's called, the function there. Then we can code it, right? And I'm not going to code the exact experiment because if you want to use the model, then for the assignment, then the exercise is to adjust the traditional way of putting these model into a way that fits the experiment. So I'm going to take an example from the Lee and Wagenmacher's handbook, which is there's 8 stimuli. These lines, 8 possibilities, which are organized along 2 dimensions, a position, whether they're on the right or on the left, and a height of the line, whether it's on the top, right, or on the bottom, or in the middle. Participants are exposed to 8 sequences of each sequence with all of the 8 stimuli in random order. And so we can simulate that. We have stimuli 1 to 8. We have height, right? That for each of the stimuli has a specific value, which I just copied from that picture, like inferred from that picture. So the stimulus 5 and 6, no, 5 and 3 have a height of 1. Right? And 7 and 1 have a height of 2, and so on and so forth. Position is the same, but on the vertical axis. And then the category is inferred by the decision rule that Lee and Wagenmacher provide us. That is 5, 3, 1, and 2 are category A, 0, sorry, and 7, 8, 6, and 4 category 1. And then do a table with these different features. And I do the plotting to make sure that it looks so well, right? And so before I had this one, and now I have this one, just to check that I coded everything. Yes?
We have position on the x-axis.
So basically each stimulus is defined by 2 coordinates.
And not the height as well, the height of the line? So that's only the height, the y.
It's the height where they are.
Yeah, so that's just position x and position y.
Exactly, yeah. It's just the traditional way of calling it is position and height, but yes, right? It's x and y. It's just 2 coordinates. Good. Then we say a sequence, and we say that for 8 repetitions, 1 to 8, we shuffle the sequence of 1 to 8 stimuli, and then we append it. So we have the 8 sequences where each of the stimuli are every time you shuffle sequence. And so then we do an experiment in which basically, given that sequence, we also explicitly code for the various properties of the stimuli, the height and the position and the category, just to have a neat table with all the data. And this is important to do because if the structure of the experiment changes, our ability or what we expect from the simulation will change, our ability to recover parameters will change, our ability to recover model will change. One of the things that we spent a lot of time during Sarah's master thesis is that, for instance, the number of features and whether they were binary or continuous made a huge difference for the ability to recover the parameters. And so as you change the experiment that you're designing, or as you change the context in which you're applying your model, doing this simulation is super important. And I know there's only 2 minutes left. But basically, here is just, and we can go through that a bit tomorrow if you want, but here is just the implementation in R of the formula of the models, right? The distance, that does the Euclidean distance across the different feature space with weights. And there's a similarity function that just does the exponential decay. And then before we even run the experiment, we assess whether the similarity function is giving us the exponential decay that we want. That's how I actually got that plot. I take my implementation of the formula and I see whether it makes sense given different parameter C values. And then what we do here is we have a function that basically runs the GCM model. That it starts with an empty list to save the probability of saying 1. It infers the number of trials by looking at the number of rows of the experiment that the function is going through. And it has some debugging, if quiet stuff. And then it says if this is the first trial, or if there are any categories with no exemplars seen yet, set the choice to random. Otherwise, for each previously seen stimulus, assess distance and similarity of the current stimulus to the previous one. And here it applies the similarity function, right? And it saves this. And then calculate the probability of saying 1 by dividing similarity to 1 by the sum of similarities to 1 and 2. And then it has a binomial function that generates a choice, right? It's nothing fancier than that. And what we can do tomorrow is to actually implement these kind of simulation either with the GCM or with one of your models to create simulated participants, to start figuring out how your strategies would work in this context. Does that make sense? And I'm going to provide instructions and feedback tomorrow. Yes.
In the beginning of the lecture, you said that you use this experiment for studying autistic children.
Yes.
Is it cognitive modeling or is it what
Both.
do you, okay.
So
what do you look at?
So for instance, the model that I was mentioning that I brainstormed with Peter could be used to test ideas that the hyperpriors in autistic individuals, or at least some autistic individuals, might be hyperprecise, meaning that even absent differences in features might be perceived as features. So if all the aliens are purple, but my expectations are so precise that sometimes I get a predictive error when saying purple on that color, I might assume that there is a feature color which is not in the pre-given feature space, right? So we can estimate how many extra features are over time sampled by the participant. That would be one way of going at that, where we test the individual process. But actually, really what I'm interested in is the interactional processes. So if we use these models in which features are verbalized according to their weight, and let's say the propensity to verbalize and the propensity to update your own prior given what yourself and the others have verbalized can be estimated. So we can start by looking at how the dynamics of the conversations in terms of very simplified expressing your assumed features and updating according to the other might be different in the two groups or according to different clinical traits. Yeah. Does that make sense?
Yeah.
Yeah. Plus, there is a lot of literature on categorization in autism, which has biases, for example, shape bias, which would lead to different expectations about weights. But they're all assessed not using cognitive modeling, but using how many errors do they make in this case, how many errors do they make in this other condition. Yeah. But yeah, but as usual, when doing, since I tag along other clinical research, right? We designed this task, but we didn't specialize it to really test nitty-gritty details of the cognitive modeling stuff, and we hope that the cognitive models can deal with that. So we optimize for the task being accepted by other researchers and participants and being enjoyable, and then try to use cognitive modeling to disentangle different hypotheses. Yeah. Cool. So thanks for today.